So, good day to everyone. Today we will take a look onto the Ram Air Turbine Red. So, this is the fully self-contained Ram Air Turbine. So it is necessary to produce emergency power in case of total loss of electrical or hydraulic power. So actually, Red can be of two types depending on the type of electric power of the airplane. So, if our airplane is equipped with AC power system with constant frequency of 400 Hz, like Boeings and Airbuses, then Red has only hydraulic pump, which is driven by means of its fan, by means of its propeller. In this case, Red supplies hydraulic power to one of the hydraulic system of the airplane, and this hydraulic system supplies hydraulic power to the flight control surfaces, to boosters, or even if we are talking about fly-by-wire, where everything is done by means of joysticks, then joystick controls boosters, and boosters are operating from the hydraulic power. So this is really essential. Otherwise, if you completely lost hydraulic power, then modern airplanes becomes uncontrollable. However, hydraulic power also can be used to produce limited amount of AC power, of electrical power. This can be done by means of hydraulic motor generator, HMG. This is the name of the Boeing. Or by Airbus, this unit is called constant speed motor generator. So names are different, but the operation is fully similar. This device takes hydraulic power and rotates its hydraulic motor. The speed of hydraulic motor is controlled very precisely, and therefore this motor drives its own built-in generator, and this generator operates with exact speed, for example 12,000 RPMs, and so it is able to produce constant frequency. On airplanes with frequency wild AC system, whereas the frequency is only approximately 400 Hz, plus minus 100, Red is equipped with both hydraulic pump and AC generator. In this case, hydraulic pump is used only to supply hydraulic power to the flight controls, like it has been done here. And AC generator supplies power to the airplane, in case of emergencies, of course. The difference between this and this is that HMG is able to keep its frequency very precisely at exactly wanted speed, so the frequency becomes very stable. Whereas Red is not able to very precisely control its speed, so the frequency becomes slightly variable. And that's why we can't use this approach in airplanes with constant 400 Hz frequency airplanes. So, exactly this one is from the Airbus 320. So this is the constant frequency airplane, like it's shown here. Therefore, this Red has only hydraulic pump, which in this case is attached from the back of the Red. So, generally speaking, Red consists of several parts. Leg is attached to the airplane from this side. Further, actuator, which is removed. Actuator is connected here. This is the deployment actuator, which helps us to release to ultimately release the Red, as well as to stow it back into the airplane. This fastening is required to hold doors So when red becomes extended, these rods also open the doors. Further, propeller. Propeller has two blades, only two blades. Propeller governor is located here. And further, hydraulic pump, which is connected to the airplane through the leg. And these two pipelines escapes from here. So here is the covers, we can remove them. And you will see two pipelines. So, the larger pipeline, this is the supply, and the smaller is pressurized line, So from here we got hydraulic power from the airplane, then the pressure is rising up, and under high pressure, hydraulic fluid is supplied back to the airplane. The bigger diameter is required because in order to reduce friction, in the flow, and therefore we got slightly higher pressure in the intake, and therefore there is less possibility of less probability of the cavitation of hydraulic pump. So that's how you can deal between two diameters. Further, this is the speed governor of the fan, of the propeller. So, in this model, speed governor implies controlling by means of oil. So, this part has centrifugal speed governor, which is here. This speed governor sends speed of the propeller. Further, it supplies commands to the oil, whereas oil is supplied by the gerotor, gerotor pump. So, this oil is not supplied to the airplane. To the airplane we are supplying oil by means of power pump, which is from the back. And for the red needs, for our needs, oil supplied by the backup pump, which is called gerotor pump, which is here. So further, this oil is used to move the piston, which is inside in the propeller hub, which is here. And this piston can adjust alpha angle of the blades. So if I will try to move it manually, I will not be able to do this, because the blades are spring loaded. You may open this cowl, here is the 4 screws, these are already opened. You have to press and rotate, So if I will remove this cover, maybe I will be able to do this. With one hand here. Of course, in real life you do not have to do this like this, because you are scraping all paint, so it will oxidize, but since I have only one hand, I have to do this very gently. So here is the seal, sealing ring. Here is nothing, and actually nothing is here because this hub is spring loaded, so we can't remove these nuts, otherwise the spring comes out. So this spring, which is shown here, just will shut outside from the propeller hub. That's why we can't go inside for more. The next question is, why do we have only 2 blades instead of 3 or 4 or 5? This is due to the fact that red is stowed in its bay, in its bay, and this bay has a very narrow opening. So if we had 3 blades, then we need very large opening. But in that case, we need only small opening. That's why we need only 2 blades. We have only 2 blades. However, if the blades, this is the opening, imagine this is the opening. If the blades will rotate inside, the red will not be able to be deployed automatically. It will just stick inside, inside its nacelle. In order to prevent this, in a stowed position, red, its propeller, is fixed by means of this rod. Here is the slot, and here is the rod. Slot and rod. So when it is put in, stowed in the airplane, it can't rotate. It becomes deployed automatically when we lose electrical power, AC power, or when we fully lose hydraulic power and there is no electrical power to generate hydraulic power. Then it starts to be opened by means of actuator, which is attached here. When it opens, this will rotate. When this will rotate, it has a mechanism which is connected with index rod. So this mechanism will, when fully extended, this mechanism will open, now it is opened. So the index pin removes once again. Index pin removes from the groove. So the propeller becomes released and now it is able to rotate. So this is the general motivation why it is not possible to put it back when it has been deployed during the flight. Because the blades will rotate, and they can be stopped in some position which is not aligned with the slot, which is in a wing or in engine nacelle and so on. So we can't deploy it back, because the propeller is not aligned. On the ground, maintenance personnel will manually rotate it back to the index position, and further, by means of stowing pump, which is also built into the deployment mechanism, they start to stow it back. So after 10 degrees of rotation, the index pin goes back, so you can check that it's fully aligned, and further you can put it back into the fully stowed position. Exactly on this red, this rod is damaged, so it doesn't catch the slot. It doesn't catch the slot, and that's why it was removed from the airplane, and now we can use it for our needs. So what else? Also, you may see a lot of wires. 3 connectors, no, exactly 2 connectors and 3 wire bundles. The red is fully self-contained mechanism. It does not require any electrical power to operate. These wires are required to show position. So here we have 2 proximity switches. Okay, where is the focus? This is the one proximity switch, and this is another proximity switch. So when I will rotate you will probably see that these proximity switches goes through this by this way, and also it goes here. So finally, when it is fully deployed, where is the focus? When it is fully deployed, the proximity switch, this one, goes down, yeah? So the switch opens, and this proximity switch, it was opened, and now it is pressed. Yeah, now it is pressed. So actually these two proximity switches are required only to show the position of the red. So these proximity switches are required to show position onto the display, as well as these proximity switches are required to operate stowing mechanism to prevent its overmove. Yeah. So just to know when it is fully deployed or stalled. The third wire bundle goes inside into the leg, and it helps us to check the generator, yeah, to check the red. It has a, actually I don't remember, do we have it on this? Yeah, here is the PMG. This is the generator pump, and this is a PMG, permanent magnet generator. And this generator, through these wires, is connected to the airplane, so its output frequency is proportional to the speed of rotation, and it helps us to check the operation of the red. Yeah, is it in a good condition or bad, and so on. So yeah, what else? Also, from this drawing you may see that here we have a filter, oil filter. This is not oil filter for the hydraulic system, no. This is the oil filter. Hydraulic system of the airplane has its own filter, which is much more bigger. Yeah. This filter is required to protect this governing part from the contamination that can come from the supply network, from the supply line. Yeah. So this filter is really small. It is located here, and you can access it from the back, so you can remove this lock wire by means of pliers. Yeah. Then you can unscrew it and you will remove this filter. If the filter becomes contaminated, in order to not to prevent oil flow, it has a bypass valve, and the bypass valve opens. And when bypass valve opens, here is the magnet. Bypass valve opens, and this magnet will be extended to the left by means of its internal spring, which is not shown here. In this case, we will see tip of the fuel or of the oil filter bypass indicator. This bypass indicator is here, so this red tip. Yeah. Now it is in a good position. Yeah, everything is good. When the filter becomes contaminated and bypass opens, this rod is released, and it appears here, yeah, for the few millimeters. And further, during visual inspection, we can see that, oh, we see this rod, so we have to replace this filter. Yeah. So, okay, that was Dowty, former Dowty. For today, this is a Sundstrand red. This is a slightly older solution. For today, it is replaced by the more modern reds. So it will stall at the speed of approximately 130 knots, whereas modern will stall with the speed which is lower, 100 knots. Yeah. That means that during landing, we are not able to extract full power from the pump. So during landing, when the speed is too low, the HMG automatically disables. This will reduce load onto the hydraulic pump, and the propeller will continue to rotate without without fails due to very slow air supply, yeah, air motion. So landing actually is done without this assistance. So landing is done only on batteries of the airplane without AC. Yeah. But during flight it's fully sufficient because flight is carried out at the speeds which are much more higher than 100 or 130 knots. Yeah, knots. So okay, I suppose that's all. Yeah. So nothing more to describe. So, thank you.